Dear students, an introduction to B.Sc Mathematics course is that what we are going to see in this video. Why Mathematics course? Now, it is a good choice that you wanted to do Mathematics course. What is that I can do if I take up Mathematics course is the natural question that arises in your mind. If you understand mathematics, then you would do any job systematically. You can become a good teacher, statistician, or a good programmer, or more than that, you'll be a good organizer wherever you are. And then for improving the performance of AI tools, artificial intelligence, it needs further improvement. So, for that, good mathematicians are always required. So, for these reasons, definitely you need to do mathematics course. Now, what are the subjects that you will learn in undergraduate mathematics? You will have these subjects: classical algebra, calculus, analytical geometry, vector analysis, transform techniques, differential equations, abstract and linear algebra, real and complex analysis, mechanics, and you have for maths the allied courses, allied subjects, and elective subjects also. So we'll see them one by one. In classical algebra, you will focus on solving equations. It may be a third degree, up to a second degree, you would have solved in plus two. Up to plus two. But given third order, fourth order, even higher degree under reciprocal equations, you will be solving them. So, how to solve them? That is discussed in classical algebra, and even manipulating expressions. What do they represent? And the properties of numbers and variables, they all will be explored in this subject. Then you also have matrices, determinants, solving a system of linear equations and polynomial equations. That is, you solve them. You will have the relation between the roots and coefficients, all that you will have in classical algebra. And it actually provides the necessary foundation for understanding more advanced algebraic concepts. Then comes your calculus. It has got two major branches. One is differential and the other one is integral calculus. A little bit you would have studied in plus one or plus two. In the more detailed properties you will have in UG mathematics. It also includes about the limits, continuity, derivatives, integrals, and their applications. And in analytical geometry, you have both 2-dimension and 3-dimension. So, using a coordinate system, you are studying geometry. So, that is what is discussed in analytical geometry. Your parabola, ellipse, hyperbola, all that will come under 2D. Then plane, straight line in 3D. And in some colleges, they'll also have 3D sphere and cone, cylinder, and so on. So, in vector analysis, you will have quantities that have both magnitude and direction that you have learned. So, a lot of application of the theorems that you will study in vector analysis. And next comes the transform techniques. It's a mathematical method that is used to convert one form of data or a problem into another equivalent but often simpler or more convenient form. Supposing you are solving a differential equation which you have studied in plus one or plus two, you want to solve them easily because some may be very complicated. So, using Laplace transform, you can easily solve them. So, those types of transformation you will study in transform techniques. And then comes differential equations. In that, you have both the ordinary differential equation and partial differential equation. So they describe the relationship between a function and its derivatives, and they are very useful to model and understand the dynamic systems. Next comes your abstract and linear algebra. Abstract algebra studies more general algebraic structures like groups, rings, fields, vector spaces, and so on. And that is actually vector spaces is dealt under linear algebra. So linear algebra deals with linear equations, matrices, and vector spaces. So mainly transformations they will be discussed in linear algebra. That is an interesting topic which are used in your computer graphics. And real and complex analysis. Real analysis deals with real numbers and real valued functions, while complex analysis focuses on complex numbers and complex valued functions. Complex analysis builds upon real analysis, but extends its concepts to the complex plane, which has more structure and leads to richer properties of functions. Then you have mechanics, and that is divided into two branches, statics and dynamics. Statics deals with the objects at rest or in constant motion, while dynamics focuses on objects with acceleration. Then you have allied and elective subjects. Like allied means you have numerical analysis. It focuses on developing and analyzing the algorithms for finding approximate solutions to mathematical problems, especially those that are too difficult or impossible to solve exactly. And statistics involves collection, description, analysis, and inference of conclusions from quantitative data. Then next comes, this is for data science, this is very useful, and discrete mathematics for this focuses on mathematical foundation for computer and information science. Operations research aims to optimize resource allocation, improve processes, and make better decisions based on data and analysis. Again, this is also an interesting subject. Graph theory is also an interesting subject. The study of graphs, which are mathematical structures used to model pairwise relations between objects. So enjoy your stay at your institution and develop a passion towards a particular branch in mathematics. And all the best for your bright future. Thank you.